In this section, we're going to be talking about measures of central tendency and variation. And what we're talking about here is like center and spread of the data. When I say center, I mean how closely the data are around a central value. And then there are also measures that deal with how far apart the data is spread. So let's talk about each one of these. The measures that we're talking about being around the center would be things like the mean and the median. And these are called measures of central tendency. The other ones that I talked about, talking about how far apart things are, they would be things like the range, the interquartile range, the variance, mean absolute deviation, and standard deviation. So let's talk about each one of these one at a time so you can kind of get an idea of what we're talking about. Okay, first up is the mean. And we talk about this first because it's probably the most important of all of the data descriptors in statistics. No matter what you do, you talk about the mean. Well, the mean has a definition, a formal definition here, and it's always denoted by this X with a bar over it. That represents the mean, and it's read as X bar. So look at what they're doing. They're taking and adding up all of their data values, all of their X's, and then dividing by how many they have. You've been doing the mean for a long time. You just may not have necessarily called it the mean. We used to call it just the average. And you just add up all of your data values and divide by how many you have. It'd be like finding the average of your test scores or something like that. Okay, also we need to talk about the median, which is another measure of central tendency. And the median is the exact middle of a data set. So in order to be able to find the exact middle, you'd first have to put all of your numbers in order from lowest to highest, and then find the exact middle. Now sometimes the exact middle is in between two numbers. So if that's the case, then you have to add them up and divide by 2 to find the middle. So median, think of the median as you're driving down the road, and that thing that's in the exact center or the middle of the road is called the median. And then finally we have the mode. And mode is the data value that appears most often in a data set. So let me show you how this works. We have an example here that says find the mean, the median, and the mode for the data shown. So first things first, we're going to find our mean, which means we're going to be adding these all up and dividing by 1, 2, 3, 4, 5, 6 because we have 6 data values. So literally we're going to be taking 60 plus 60 plus 70 plus 95 plus 95 plus 100, and we're going to be dividing all of that by 6. So if you pull out your handy dandy calculator and do your addition, when we add up all of the numerators, that turns out to be a total of 480. And then when we divide that by 6, our mean should be 80. So that would be our mean for this data set. Now then we need to talk about the median. And when we talk about the median, again, we're talking about the exact middle. So if I were to look at this data set, then I could look at the first and the last and kind of mark them out, and then the next to the last, and then the middle two. My middle or median is going to be right here in between these two data values, right smack dab in the middle. So I need to figure out what that would be by adding up 70 plus 95 and dividing by 2. So in this case, my median is going to be, when we add up 70 plus 95 and then divide that by 2, we should get 82.5. So that would be our median. Now talking about the mode. Remember, the mode is what appears most often in a data set. So let me erase what I had here. And looking at these data values, you see that 60 appears twice and 95 appears twice. So we actually have a tie between 60 and 95. It is possible for a data set to have more than one mode. This is actually called a bimodal data set. Bimodal meaning it has two modes. Generally, though, you just have one, whichever one of these would appear the most times. But in this case, we had a bimodal set. Now, by figuring out our mean and median and mode, this leads us to another interesting set of things that we can talk about. Let me move to the next page here, and that would be where we start talking about spread. And talking about spread, we want to talk about how far apart our data is. Well, we call that the range of the data values. And that literally is where you take the highest number and subtract the lowest number from it. And you see how far apart all of your data values are. Now, when we look at range, we can also look at the median, which would be the exact middle. And then, and technically, the median is also referred to as quartile 2. If you think about breaking your data up into 4 equal parts, well, the exact middle would be half. So we would call that quartile 2. Now, the middle of the first half, we would call that quartile 1. And the middle of that second half, we would call quartile 3. Let's figure some of this out, and I'll show you how this works. Here we have an example that says find the range, the inner quartile range, the median, the lower quartile, which is quartile 1, and the upper quartile, which is quartile 3, for the data set. So here we have our data set, and if you'll notice, they are all going in order from smallest to largest, which is what we need. Now, if I were to look at the middle here, and let me just start kind of blocking out matching pairs. Third one's inside, fourth one's inside, fifth one's inside. I can see the middle is exactly here where 70 is. So I'm going to erase everything I have, and I'm going to write that as being my median, because that's the exact middle. Now, looking at just the first half of the data, just looking at the first half, I want to find the middle, and it would be right smack dab in between these two values. That would be my first quartile or the lower quartile, depending on how much you want to call it. But it's right smack dab in the middle of here, so I would have to figure out what's in the middle. I'd have to add these two up, so 40 plus 50 would be 90, divided by 2 would be 45. So my lower quartile, or quartile 1, is the number is 45. If I do the same thing in the upper end, on the top side of the median, if I look at blocking these numbers off until I find the exact middle, and then I'm going to erase what I have, I see that it's right smack dab in between the 80 and the 90. So right smack dab in the middle of there, that's my quartile 3, or my third quarter. You can think about them. Again, we have to add these up and divide by 2 in order to figure out what our median of the upper half is. So 80 plus 90, well, that's going to be 170. And then whenever you divide by 2, we should get 85. Now the 20 here, we call that our lower extreme, because it's the smallest number. And the 100 over here, we call this our upper extreme, because it's the highest number. Now they did ask us to find the range of the data, so let's find that. The range here is nothing more than the highest data value minus the lowest data value. So it would be 100 minus 20 is 80. That means that those scores, or whatever they are separated by 80 points. Now the interquartile range. When we talk about the interquartile range, we're talking about how far is it from Q1 to Q3. So again, we would just need to subtract those numbers. 85 minus 45 is 40, so that would be our interquartile range. Now this may seem silly, figuring all of this out, but it really does help us to create a kind of a graph off of these numbers, and that helps us to visually be able to see exactly where our students' maybe test scores are clustered around, or how far apart they are. And that's called a box plot. So let me show you how a box plot works, and we're going to use the data that we just did up here in order to construct this box plot. First things first, I'm going to draw a number line, and I'm going to mark it in increments of 10, 40, 50, 60, 70, 80, 90, and 100. Okay, my lowest extreme was at 20, so I'm going to put a dot there at 20. My upper extreme was at 100, so I'm going to put a dot there at 100. Now the interquartile area, we draw a box. It's the lower and the upper extrema that form the whisker part of the box and whisker plot. So if I look at the median, we knew that was a 70. I'm going to put a line there. And then quartile 1, that was at 45, so I'm going to draw a line there. And quartile 3 was at 85, so I'm going to draw a line there. And now we connect the lines to create a box and go out from the box to the lower and the upper extremes. This is what's called a box and whisker plot. And we can look at this and we can see that the middle data value was 70, but we have, quite a few scores that were below that, all the way down to a 20, and then the same number of scores that were above that to 100. So that tells us a lot visually about what our scores looked like.